Welcome to Calculus Crush. Today we're going to be doing a definition of the derivative question. So we're going to find the derivative of g of w equals 1 divided by the square root of w using the definition of the derivative. This would be a very simple question. If we were to use the power rule, it would be maybe a 1 or 2 line derivative. It's going to be quite a bit more work, as we'll see, using the definition of the derivative. Let's start out by writing down the definition of the derivative. So that would be g prime of w. Prime designates the derivative. It's a limit as h approaches 0, g of w plus h minus g of w, all divided by h. So if you don't know where this comes from, you can click on it and it'll link you to another video where I derive this. This is the definition of the derivative, or the definition of the slope of the tangent line. You can see where that comes from. So that equals the limit as h goes to 0. So we know what g of w is. It's 1 over square root w. G of w plus h, all we have to do is find the w's and replace them with w plus h's. So that'll be 1 divided by the square root of w plus h. That's g of w plus h. Now minus g of w, which is just the function. And that's all divided by h. Now, the first thing we need to do is come up with a common denominator so we can merge these two fractions together. In order to do that, we need to multiply the top and bottom of this fraction by the square root of w, and we need to multiply the top and bottom of this fraction by the square root of w plus h. So after we do that, we get this square root of w minus the square root of w plus h, all divided by these two guys multiplied together. So that would be the square root of w times the square root of w plus h. And that's all divided by h. Now for the next step, we need to get rid of these square root signs up in the numerator. In order to do that, we need to multiply it by the conjugate. So I'm just going to do it on the step before, times the square root of w plus the square root of w plus h divided by the square root of w plus the square root of w plus h. Now I'm allowed to do that because this quantity here is just equal to 1. Right? It's basically a over a, where a is the square root of w plus the square root of w plus h. This is a clever way which allows me to get rid of the root signs on the numerator here. So square root of w times square root of w is just w. And then we have the square root of w times the square root of w plus h. But then we minus the square root of w times the square root of w plus h. So those cross terms cancel. And then the last term we have is the square root of w plus h times the square root of w plus h. Now on the bottom, so we've got the denominator here. This is also a denominator, so I'm just going to move the h up. We have h times the square root of w times the square root of w plus h, so that first part. And then we have multiplied by, let's put another bracket, the square root of w plus the square root of w plus h. So now let's expand the top here, equals the limit as h goes to 0, w minus h, all divided by h times the square root of w times the square root of w plus h times the square root of w plus the square root of w plus h. So we can cancel out these w's here, and all we're left over with is minus h over h times all this. So we can cancel out the h over h, and that's exactly the whole purpose of doing all this fancy algebra, rationalizing the numerator, is so we can pull out an h from the top and cancel it with the bottom. That h over h, if we try and take the limit as h goes to 0, is going to give us 0 over 0, which is undefined. But once we cancel out that h over h, now we can actually take the limit as h goes to 0 and get an answer, which would be the derivative. We've canceled out the h's on the top, so I'm going to write the bottom first because it's a bit longer. We got square root of w times the square root of w plus h times the square root of w plus the square root of w plus h. And on top is just a minus 1 because we've canceled out that h. Now we can actually take the limit. I'm going to go up here. So everywhere we see an h in this expression, we need to make it 0. So all we're left over with, I'm going to write the bottom first, is the square root of w times the square root of w times the square root of w plus the square root of w. And all of that is underneath minus 1. So let's simplify here. We've got the square root of w times the square root of w, which is just w, times 2. So I'll put the 2 in here, square root of w, negative 1. And this is our final answer, g prime of w. There's many different ways to write this. I kind of like this method of writing it. Even though we can combine these two w's here, I prefer having square roots and whole kind of whole powers here. But I'll show you another way to write this. G prime of w is also can be written, this is another way, negative 1/2 times, now this is w to the power of a half and w to the power of 1, which would be w to the power of 3/2. But since it's on the bottom, it's minus 3/2. So this is another way you can write it. It's probably nicer to write it this way, but if we had used the power rule when solving this, this is exactly the answer we would get. And then we could make the decision to leave it there or maybe take it to this next step. Okay guys, thanks for watching. If you have any questions, just leave them in the comment section. Please subscribe. I'm going to be posting lots of videos using different differentiation rules, such as the chain rule, power rule, product rule, quotient rule, etc. Until next time.